Hey guys, this is the second part of your videos for mixtures. 1.3 classifying matter as pure substances or mixtures based on composition. So the first video was all about the pure substances, talking about elements and when you combine them, how they're still pure substances even though they're compounds. Now we're going to talk about mixtures. So mixtures are a combination of two or more substances where there is no chemical reaction. So, for example, this pizza below, if we take the cheese off and the meat off and whatever toppings you have on there, you can pull each piece of that off and there not be any problems. You would be able to eat those other things separately. If you have pepperoni pizza, you can pull the pepperoni off and just eat the pepperoni. And then you can pull the cheese off and just eat the cheese. And then you can eat the crust and the bread part without the other stuff on top of it. So that is mixing them together without a chemical reaction. Another example would be salt and water. You can stir those together and the salt will dissolve into the water. And when you're done, if you wanted to separate them back out, you would just boil the water and the water would evaporate off and the salt would remain. So those would be a combination of a mixture with two substances, the water and the salt, that aren't being chemically changed, and they can be separated without any problems. So this picture is not on your paper, obviously, but I wanted to show you the different types of mixtures. The first one's showing you mixtures of elements, and so this is showing you oxygen and helium. Those are single things mixed together to make something, but there's not a chemical reaction. And then we have mixtures of compounds, which is showing you alcohol and water. And you can see that here is a couple of water molecules, and then that would leave this as the alcohol molecules. There are mixtures of compounds. These things are separate entities, but they're mixed together. And then the third one is mixtures of elements and compounds, like the air that we breathe is not just O2, it is a whole bunch of stuff. There's water, there's oxygen, and these are some other parts to what we breathe in every day. So we're going to talk about characteristics of each, just like we did in the first video. Each substance keeps its identity. So like I said, you've got the pizza. The pepperoni is still the pepperoni. You're not losing anything there. It can be separated by physical means. So I gave you the example of the salt water. That is using evaporation or distillation, filtration, using magnets, or chromatography. We're going to use chromatography. I'm having a hard time with that word this morning. Chromatography in a couple days, so you'll be able to see what that looks like. And distillation is just boiling off of, and then you can collect what's being boiled off to separate it as part of separating these things. Filtration, you can see in this picture here, is pouring things through some type of filter and the big stuff staying in one place and the liquid pouring through. That'd be filtration. You're not changing anything. Everything is being separated by physical means. Solutions are substances that appear to be a single substance, but it's actually made of two or more substances evenly distributed. Like, look at your Kool-Aid. You've got the powder and the water and you mix them together and you have Kool-Aid. And so it looks like a single substance, but it's really got two or more things in there. They have the same appearance and properties throughout. So here's just showing you take the sugar or the Kool-Aid packet, there's your water, and it mixes it through to give you this substance that gives you the Kool-Aid. That is a solution. We've talked about some of these terms before. This is a homogeneous solution. And if you remember, homo equals same, so they are the same properties spread throughout. There are 3 types of mixtures: solutions, suspensions, and colloids. And if you remember from when we talked about states of matter, we talked about solids, a liquid, and a gas. And then we talked about plasma, and you may have also remembered hearing the word colloids, like we said jello and paint. So sort of the same idea. This is like whipped cream or whatever, that's a colloid. Oops, I went too far. And this is Italian dressing. Okay, so we're going to talk about that also. So if you remember when we were talking about osmosis and diffusion, we talked about solute and solvents. And so a solute is the substance that is dissolved. It's the thing that is usually the lesser amount. And then the solvent is a substance in which the solute is dissolved. It does the dissolving, in other words. So in the example below of salt water, what is the solute? Salt, very good. What is the solvent? Water, very good. That is what you mix the solute in and you stir it up, and the solvent dissolves it. So that's just a little refresher course on those terms, because we'll see them a lot during this section. So examples of solutions: salt water, tap water, alloys such as brass and steel. Those are mixtures of metals. Air, this right here, is what we breathe in all the time. Nitrogen, you know that there's 78% nitrogen in our air? And then, hang on, let me adjust this so you can see. Oxygen is only 20%, and then there's argon, and there's other gases, which is 0.04% of what makes up our air. So that should be an interesting thought to you, that our air is a mixture of stuff. It's just not pure O2 like you might have always thought. So moving on to suspensions. Oh, you know what? Go back. Let me go back. Write this part down on your paper on the right-hand side next to that solute and solvent section where you have a little bit of room. Just write percent in the air and write this down. Nitrogen, which is considered N2, is 78%. O2 is 20.95%. Argon is 0.93%, so less than 1. And then other gases make up 0.04. I know that's cut off on the bottom, but it is 0.04%, because this is something we'll talk about again in future lessons. All right, now let's talk about suspensions. Suspensions are a mixture in which particles are dispensed throughout liquid or gas, but are large enough to settle out. They're considered heterogeneous. So remember, hetero means different. Think about this snow globe. Oh, hold on. I'll come back to the snow globe. Let's keep going. Particles are too large to stay mixed. Therefore, they settle. So we've got, this is Italian dressing. Italian dressing is considered a suspension, because you can shake that up and then all these particles mix all throughout, and then you put it on your salad and those particles come out also. But when you're done, you sit it back down on the table, all those spices settle into the bottom. So that's what it means by they settle out. They're settling to the bottom, and they're not dissolved inside of it because their particles are too large. A snow globe is another example. You know, all the snow settles on the bottom until you shake it, and then it flutters all around the whole globe until it again settles out. So those are suspensions, okay? Those are examples of suspensions. And then a colloid are mixtures in which particles are dispersed throughout, but not heavy enough to settle. So their particle size is between a solution and suspension. So like solutions were your Kool-Aid, and suspensions where your Italian dressing, a colloid is the whipped cream or the jello, mayonnaise. Those things are what a colloid example would be. So this was just a quick overview of mixtures. There's 3 types. Write them on the bottom of your paper what the 3 types are. Solution, suspension, and then a colloid. Okay? And then we will be working on figuring out what substances are pure and what are mixtures based on how these things are composed and made up.